everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it. Pause the video, come back, and we will do it. Okay, here we go. What is the positive solution to this given equation? A standard way of doing this is to bring a new variable. Let u equal 3x, and then we write it as a quadratic. U squared minus 4u minus 12 is 0. And then a standard way of solving quadratic equations is to factor them. Two numbers that multiply to negative 12, but I always say add or subtract, but in this case subtract. That would be 6 and 2, and the 4 has the negative sign, so this goes like this. Now we want the positive solution, so u would be 6, but u is equal to 3x, so x would have to be 2. This is just standard straight. Seth would say, follow your nose of doing it. I don't know. Did I make a mistake? Of course, you always want to check. No,
that's good. Yeah.
Yeah, but I don't. But usually, you don't have someone telling you you did a good job. I need to check it myself. So I do a quick check. When I factor, I always like to multiply to check. I do a quick foiling here. This does look correct. So this looks correct. Yeah. So this is probably correct. If you really want to
it's easy to use your eyes and calculate minus 6 plus 2 to get minus 4 and check it against this.
Right.
And then to take minus 6 times 2, you get minus 12. Check that.
But I'm wondering whether if one's checking, maybe you should just check x is equal to 2 directly into this.
Nah. That's too much calculation.
Yeah. Okay. Yeah.
Okay. So I, instead of saying standard way, I look at this and I see what's staring me in the face is 3x.
Yeah.
So I solve for 3x.
Right.
And if you to write out a full explanation, you'd write this. But when you're taking the SAT, it's a good idea to use to solve the problem quickly.
Oh, you're saying.
So, and the principle behind all this let business, it's not an arbitrary, unexplained application of a standard rule. It's that 3x stands by itself. It's the only place x, the unknown, appears is with a 3. And so finding the value of 3x that solves the equation really leads you to finding the value of x that solves the equation.
Right.
And then you make sure to pick, since 3x is positive whenever and exactly when x is positive, you just do that. So you could just use your eyes on this. Although it may help when you use your eyes to actually see, what Joel writes. So you might want to write that. And it's good to add what you should not do. Don't do this. X squared minus 4x minus 12. Don't do that. Because that gives you the risk of solving for x and getting x equals 2, and then giving x is 2 as the answer. Don't do that. That's a danger. Is a thing that could. Doing that calculation, you might forget that the answer is really 3 times 2.
Right.
Don't do that. If you're going to rewrite the equation, use a different variable.
Exactly. Introduce a new variable. Very important. So this
I like the word use. Introduces has too many syllables.
But I can't edit using using, forget it. Forget it. So they call this equation in what's called quadratic form because it's in quadratic form if you consider the 3x as what you are as the very, I don't know what Seth would call 3x, but generally the vocabulary in this equation is in quadratic form. So
I wouldn't get hung up. I wouldn't get hung up on what form they call it.
I agree. Yeah. So basically, Seth's saying that you could just notice that you could write. You can write this. You could think of this as you could think of this directly. You could just write this here, the thing I'm underlining in blue, as the solution or how to solve the equation, because the 3x goes in here. Yeah, then you go directly there. Then you see 3x minus 6 is equal to 0. X is equal to 2. When you have a quadratic equation that's in factored form, each of these makes setting either of those makes the equation true. So 3x plus 2 equals 0 gives you one answer, one solution to this equation, and 3x minus 6 equals 0 gives you another solution to the quadratic equation. And most of the time, quadratic equations have two solutions, but not always. They sometimes have one solution. So that's about it. Now, we don't have the benefit of looking at how the SAT people answer this question, so we're just on our own here. Anything else? Oh, right. Let's ask the four big questions. One, calculator, not even a question here, because this is in the non-calculator side of an old test. So if they gave this question on the newer test where a calculator is allowed, a calculator really doesn't help. How would you do this problem different from school? Probably not. You would probably do this problem exactly the same way. It's not a multiple choice question. So the question about whether you could not even solve this, if we just look at the answers, will help. Of course, it doesn't apply because it's not a multiple choice question.
Some teachers might want you to actually write something like let and tell us the letter that you are using for the new variable.
Yeah. I always like to do problems the same way. Stays organized. Now we're left with the only question here that's relevant. What's the main idea? What are they testing to see if you know on this question? So, looks like they're testing to know whether you can solve a quadratic equation and also whether you could solve a quadratic equation that is in this, whether you could solve an equation that is in this word that Seth doesn't want me to use, but quadratic form. If you use a quadratic equation that doesn't initially look like a straight, simple quadratic equation, although Seth hates probably when I say that, because
I would say number one, subject of quadratic equations and how to solve them.
Yeah.
That's only number one. Number two is the idea of variables and more complex unknown expressions.
Yes. That's right. That's right. And a good way to deal with more complex unknown expressions is to define a new variable for those more complex unknown expressions and then deal with that new variable. Right. Yeah. So those are the two big ideas. Yeah. Good. Okay.
The second big idea. The second big idea will lead you to not do the valid mathematical step and multiplying this out, so you get 9x squared.
Oh, yeah.
Minus 12x minus 12.
So that means we have.
That is a stupid.
Right.
It's a mathematically mathematically sensible calculation step, but it is shall we say, unwise.
Yeah.
It's an unwise choice to take that step.
Right. That's right.
You know?
That's right. That's right. That is an alternate way
Yeah.
to do it. What was I going to say? But guess what? If you had this question on a calculator test, which now the SAT is all calculator, you could actually write this out, pop it into the Desmos calculator they give you, and get the answer.
It will. You could pop in an equation. It'll tell you the solutions.
No, it'll tell you where it crosses zero. It'll tell you where.
Oh.
And you can grab.
So you could plot it.
It's going to be a parabola. Yeah. You pick off where it crosses the x-axis, and that's the answer. Yeah, so believe it or not, calculator is actually a way you can actually use a calculator to do this problem.
Yeah, when you have the modern Desmos calculator, where you could type in. Yeah. Quadratic expressions.
Yeah. Yes. And then,
so you could type it in. You could type it in as they give it to you.
You can probably type it in here with the parentheses, but
that's what I mean. Yeah.
That's right. So wow, look at that. Sometimes a lot of times we make mistakes. The mistake we made here was whether the calculator can help you or not help you. Of course, calculator can do this problem for you.
But again, I think it's. I don't know, for us, who've grown up and done both at school and afterwards, lots of factoring for practice. It's fast. I think it's faster to just do it with your eyes and mind.
Well, when they wrote this question, they didn't allow you to use they didn't allow you to use a calculator. But now if they give this question on the new test, you can use a calculator. It's where the curve crosses the x-axis. Then those would be the two answers.
The x coordinate of where the curve crosses the x-axis is the solution. The x coordinate is a number, and that's the solution. Where the curve crosses the x-axis is a point.
Right.
And that point is called an x-intercept.
Yes. Yeah. By the way, the other thing, which of course we don't really have to say because we'd say it all the time, is you also have to know how to read a question. And you also have to make sure you're answering the question. But that always goes without saying. I mean, that goes without saying for every question, even on the English side. Yeah. So, I guess that's it. So you actually can use a calculator.
Yes.
Yeah.
Okay, I think we're done.
I think we're done.
Done for today.
We're done for today. Okay, so Joel.
Time for lunch.
Yeah, we usually film this around lunchtime. So I'm Joel. I have a PhD in mechanical engineering. It's my brother Seth's PhD in math from MIT. He's been professor emeritus at SUNY Albany, State University of New York and Albany for many years. He's now retired. We're here to hopefully offer different approaches on how to do different the math SAT questions. You can tell it's getting close to lunch. And we strongly advise you to do as many practice tests as you can to figure out what your weaknesses are, what questions you need to practice more. You can go to Khan Academy. They have questions sorted by type. Practice on the questions you're weak on. Practice even the questions you're strong on so you don't make stupid mistakes. And then do as many practice questions from the SAT, from the College Board that they offer. And just practice, and learn from your mistakes. Really important to do that. Okay, so I guess we are done for today. Okay, please leave us comments. We appreciate all the comments. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com, and we will do them here. Okay, everyone, have a great day.